Dr. Mansoureh Jeihani is the director of the National Transportation Center at Morgan State and the Smarter Center. As we will discuss today, she has a multidisciplinary background in civil engineering and transportation systems, economics, and computer engineering. Dr. Jeihani has more than 17 years of experience in applied research in transportation planning and modeling, traveler behavior, intelligent transportation systems, connected and autonomous vehicles, traffic safety, artificial intelligence, and equity. She is the chair of the Distracted Driving Strategy 3 Maryland Strategic Highway Safety Plan and the co-chair of the Maryland Connected and Automated Vehicles Technical Subgroup. She is also a member of the Transportation Research Board's AI and Advanced Computing Applications Committee, the Council of University Transportation Centers, the Maryland Quality Initiative Innovation Subcommittee, the National Cooperative Highway Research Program Panel, and the Behavioral Traffic Safety Cooperative Research Program Panel, among others. It goes without saying that Dr. Jeihani's involvement in civil society and research institutions is truly expansive, and I'm thrilled that we are finally sitting down with her to discuss connected vehicles, intelligent transportation systems, and the future of our cities on Smarter Transportation Talks today. Dr. Jeihani, welcome to the program. Dr. Jeihani, you are muted.
I'm sorry. Hi, Joe. Hello, everyone. Thank you, Joe, for having me.
Absolutely. Well, let's dive right in then. So on the last transportation talk, we had on Dr. Brian Park from University of Virginia, and he gave us a bit of an introduction to what connected and autonomous vehicles are, just really the basics. But I would love to hear that again in your own words. So tell us a little bit about what connected and autonomous vehicles are, and maybe a little bit about what interested you about them personally, what got you interested, and how they connect to some of the main themes in your research.
Yeah, so connected vehicles are vehicles that have communication capabilities, and they can send information and receive information to each other among vehicles, so vehicle to vehicle, or vehicle to the infrastructure, which is traffic light and other components at the intersection or on any of roadways. And also even vehicle to pedestrian and to bicyclists and some and others. That's connectivity, but autonomy comes on top of that. That those are the vehicles that have some kind of autonomy features that it can go from. There are categories from level 0 to level 5. Level 5 being fully autonomous, driverless cars. But we have different levels of, like, level 1 is having some of the ADAS that a lot of you guys have it already in your car, like collision forward warning and some other warnings that you get in the cars. Those are make it autonomy. So we are working here more on connectivity and connected vehicles at the intersections in here.
Great. And can you go a little further with that and connect it to some of the other research themes that I know you care a lot about? You know, if you reference your really extensive CV, you'll see that safety and equity come up a lot. So what do connected and autonomous vehicle systems do to promote safety and equity across the transportation network?
Right. So this connected automated vehicle technology has been used a lot by researchers and also practitioners to solve mobility and equity problems. Mobility and safety problems. And most of the focus has been on vehicles, but we are saying here that we need to use this technology to reduce the gap that is existed already in transportation system, not to increase the gap. We should not use these technologies only on expensive cars that only certain people can afford. So how can we use this technology to increase safety and equity? So safety for all. And also mobility. And that's the way that we have been pursuing that, using this technology to increase safety for vulnerable road users, not necessarily for cars, for pedestrians, bicyclists, scooters, and people on wheelchair. And how we can do that is to equip mostly instead of equipping mostly on the cars, equipping the roadways and also public transit and active transportation modes. So that's why we're putting those equipments in near Morgan State and thinking of we're going to expand it and do it more in the city, mostly the places that have safety issues and for people who cannot afford that. And put the equipment also in, instead of expensive vehicles, we can put it on transit. We can put it on shuttles and buses and trains. So they can be used. And also we are working on stuff to give those information and those data and warnings to pedestrian and bicyclists and people who are on the road. They're the most vulnerable people that using the road. Those people can use this technology and receive those warnings. Let's say if there is a vehicle coming close to a pedestrian, going to be hit by a pedestrian, both vehicle get a message and the pedestrian get a message. So they both will aware and hopefully that conflict, the crash won't happen.
I think that's a good segue to talk specifically about the smart intersection. That is the system that exists on the roadways near Morgan State University that employs a lot of the technologies you're referring to. But if you could, Dr. J, could you kind of paint a picture about the hardware that has been installed both at the intersection and in public transit vehicles? And once you've defined that hardware, what does it actually do? And how does it all work together to hit these main beats of connectivity, communication, more autonomy, and particularly in the interest of protecting vulnerable road users?
Yes, so we installed LiDAR, also cameras, CCTV, roadside units at the intersections near Morgan. And also we put onboard unit in Morgan shuttles. So the Morgan shuttle with the intersection, they can send and receive message to each other. When the shuttle passing through the intersection, it gets safety messages and also messages, information about SPAT, signal phasing and timing, all the information about what is the signal phasing right now, how many seconds to red or green, and so on. So this equipment, they are communicated via wireless, and all the information is being sent in here to our lab. And we have an edge processor at the intersection that in real time is getting all of this data, processing it in real time and put in a dashboard, and we get the dashboard in real time in our lab. And LiDAR is by light detection. It's something like radar, but it's by light. It has a 360-degree view of the intersection, and anything that passes, any object that passes through the intersection is being detected by LiDAR. And we get all the information all the time, 24/7. And the good thing about LiDAR is anonymous. So we're not going to know, we're not going to see the person's face, or we're not going to see the car, the vehicle's tag and title, and we're not going to see what is the license plate. So it's anonymous, and using AI, we are recognizing that this is a truck, this is a bus, this is a pedestrian, this is a bicycle, and all of that data being stored and also analyzed in real time. And we use it for so many different applications: static, sending static messages, dynamic messages, and storing this data to look at how many near misses has been happening. Not necessarily crashes, but all of near crashes that happening at the intersection. How many unsafe crossing has been happening. What has been the SPAT data. And we analyze, we can go back all the way to, we can look at few days to few months to even a year, And we can look at the data and find out what are the problems, where are the locations or approaches that are most dangerous, they have more of the conflicts, and how we can resolve that problem. And that we call it a passive intervention, that we are looking what has happened and analyzing it. But also we are looking at the real-time application that recognizes what is happening at the intersection and predicts if any conflict is going to happen, any crash might happen, to warn the drivers and also the vulnerable road users, to warn them, so hopefully that we can prevent that crash.
I know one of the major challenges that you face in deploying connected and autonomous vehicle systems is in communication, specifically the communication that exists not between vehicles or the infrastructure in vehicles, but that which takes place from the infrastructure to humans or vehicles to humans, because you're taking bits and turning it into actionable information that people often need to utilize in split seconds, especially if it's in the case of safety, especially if you're trying to avoid a crash. So how have you and your team gone about addressing that problem in providing humans at and around the intersection with actionable information to keep themselves safe?
Right. No, we are working on that. It's a very hard problem. As you mentioned, the communication, the latency, because by the time you want to calculate and send it, and this device sent to the other device, the other device sent to the other device, it might be too late. So for real-time applications is a real challenge. A lot of academia, universities, and also private companies are working on those kind of problems. And there are some solutions. We are working on that. We are working on TTC, time to collision, that is trying to predict if the crash may happen, if that vehicle and that person are going with the same speed and the same direction. So it keep predicting in real time. And if you get to a zone that we will give that warning that the crash might happen. So giving that warning. So we are working on it. It's hard. And besides the latency and the communication, the time that is of essence, the other problem is that if we send it through RSU, roadside unit, it broadcasts to everyone who has those kind of devices and receive that message. That might become problematic after a while. People may get insensitive to it. If you keep receiving a message that is not even related to you, it might be another person on the other side of the intersection, or it's one car, but the other car is getting it as well. So we are working on that, how we can make it more personalized and more focused on only at least that direction or those people who are involved, instead of everyone at the intersection gets those messages. So they are all work in progress, and they are very challenging.
I think it is really important to note how you've made use of both the technical aspects, the technical knowledge that goes along with CAV deployment, that being things like data analysis, artificial intelligence, which I hope to get to soon. And also, as you were referencing before, the behavioral aspects of travel and the fact that you don't want to inundate people with too much information or make them numb to the notifications in general. I do wonder, what role do smartphones play in both alerting people to potential safety threats, the intersection, or maybe other kind of notifications that with respect to the transportation system, and also as a data collection point, as a sort of a spatial tracking device that most people, though not all, have. What role do smartphones play in the CAV deployment system?
Right. Some people, some places have been working on putting apps and using smartphones. We have not done that in here yet, but cell phones and I mean smartphones and apps can help to personalize and also to get and send information. But there are a few problems with using cell phones. One is the equity problem. Like in Baltimore City, only 65% of people have smartphones. So what about the other 35% of people who do not have that? The other problem would be the cell phones. The reliability of getting information depends on the service of their network provider. And if they don't have a good service, they may not get that. And they should have like unlimited data to have their data open to get all of the information and data. So it's going to cost people. And then also the security of it. What if the people putting a lot of different apps on their cell phone, some of them are not safe, and so the information might get into jeopardy. So that's why we haven't focused on the cell phone yet, but we will do that as well, at least as just a backup plan. But we are working more on more secure devices and more devices that to be at the infrastructure and not to put so much on the cost and responsibility on people.
I would love to get into your vision of scaling this technology. One of the themes that I had plucked out in preparing for this technology, or for this talk rather, is that we have an intersection. That intersection will be scaled to a corridor. That corridor will be scaled to a city. So, would you please describe what are the benefits that come with scale in connected and autonomous vehicle technology, whether that's, gleaning more information from wider data sets or so forth?
Yes, having only one intersection not gonna solve the whole city problems. It's gonna resolve just one little area, and that's why. And it's not easy to make to put this technology in the whole city. That's why we start from a small scale, from one intersection. We increase it. We are increasing to a corridor, and from corridor, so we're going to put in other corridors, and then little by little become the whole city. One of the problems that we had was to convince the city and the policymakers to show that there is a lot of benefits doing that. So because it costs, but this cost is worth it, and especially now that we can get a lot of federal money on expanding this kind of technology. We can work with the cities, with counties, and other jurisdictions to apply and to get those kind of funding to use it and upgrading their infrastructure. So, but when we did one, and now it's a corridor, small corridor that we have. When we bring people from cities, counties, other places, state, they see how much information they can get, how much this information can help them to reassess how they can make the intersections and the city safer, the corridor safer, and how much is worth it. And it's not only for certain people, it's gonna increase safety and mobility for everyone. And that's how we are going. And so after we had this intersection and our corridor now, we have got a lot of requests from different agencies that they want to scale that they want to use that on this corridor, that corridor. And so that's how we're going to go from we started from one intersection to a corridor, and little by little, we're going to go for the whole city. And the wider network that we have, the more benefit, and that the benefit doubles and triples and exponentially goes up, because then you can have a network of all of those information, and those information are connected to each other, so we can get more and more benefits out of that. And so we are making a traffic management center like internally here at Morgan. But let's see when the real traffic management centers at each of those counties and cities, when they have that, how much work they can do. And we have shown that in our pilot study.
Mm. So those benefits you're alluding to, that those are mostly things like improved traffic flow and true improved transit reliability, things like that, mostly mobility focused when you're talking about the network effects of scaling.
Right. So scaling increases mobility, and each of the separate one increases safety, but together mobility and safety. But as you mentioned, yes, there are so many applications for emergency vehicles. So we can give them priority so that the traffic light can change to green when emergency vehicle is approaching. We can give priority to transit. We can and we can connect these the network of one city or one jurisdiction to another one. That's why we're working on interoperability.
As you scale these systems up, you're collecting more and more mountains of data. Um, it follows then that it becomes much more difficult to process and make sense of these mountains of data over time and as they get larger and larger. Um, how are you going about this problem? And is artificial intelligence a primary way of addressing it?
Yes, as you mentioned, so there are there's a lot of data. Even in one intersection, we are getting terabytes of data. And imagine when we have like hundreds of thousands of intersections. It's a lot of data. Data is gold, is power, but when it's too much, you don't know what to do with it. So that's why we are putting edge processors at the intersections to process the data in real time and get the information that is needed, that is essential, and remove all the other information that we don't need it anymore. So that's how we can manage and have a smaller data set. I mean, we might miss some stuff that maybe later would have helped us, but that's the solution that we came up with, at least for now. But if down the road we learn, okay, I need to store this and another variable, another data as well, we will add to that. But so in a large scale, that so it has to be like a traffic management center that's seeing all those intersections live, and so seeing the information that is needed, that is coming to the real-time dashboard. So people who are in the traffic management center, they can see and they can address the data, address the problems in real time. So the bigger network and the more widespread that is, the harder to handle, but also the easier to flow, and have a flow of vehicles with less delays. So we can coordinate, we can find out like there is an incident in here. So before even people get to that area and it gets backed up, way before that, they can find out that there is an incident, so they can reroute way before getting to those long queues. An emergency vehicle is coming, so the traffic light becomes green for that emergency vehicle, it passes. The buses can operate much smoother and better with transit signal priority, and also sending the information where they are and how people can get on time. All of that gonna make a much smoother and better network and transportation network. But yeah, it's harder to handle, definitely.
I wondered while we're preparing for this interview how your experience in developing and studying complete streets informed your vision for what connected and autonomous vehicle systems can be, and how you might go about addressing some of the challenges in implementation or in working with stakeholders or things of that nature. So, how did your experience with complete streets inform the smart intersection and the smart corridor that followed?
Um, yes, when we were doing complete street study, it helped me understand more that we can use new technology for more than vehicles. And our streets, our roadways should accommodate more than just vehicles. So historically, we have been just adding more and more lanes and more highways, and just increasing the capacity just for cars. But now we are thinking about that's not sustainable, and that's not the best way. So we are trying to put roadways to accommodate transit, pedestrian, bicyclists, scooters, people with wheelchair. So all of that together, it can work if we use this technology, also this technology to accommodating those as well, and not only to be for cars. So that's how we came about, okay, connected autonomous vehicles. A lot of places are working on it, but a lot of places looking at, they have like the test bed that is an isolated test bed, just looking more on autonomous vehicles or connectivity for vehicle to vehicle. So we brought it into the city streets. It's not even campus streets. They are in the city, in Baltimore City, next to the campus, but all vehicles are passing through all of that. So we are putting it as a mixed traffic, and it's in the places that we have bike lanes, and also we have a lot of pedestrians. So we are seeing how much we can affect pedestrian and bicyclist safety, how much we can work on that and increase safety for vulnerable road users.
I want to remind our members of the audience that you are more than welcome to ask your own questions using the chat or Q&A feature, and I will incorporate them as we move into the final part of our interview. With that said, I want to open up the conversation a little bit and talk a little bit less about the smart intersection in particular, and more about how it relates to deploying new technologies more broadly, working with partners in the transportation sector, and how you sort of act as a leader in that space, because I know you have a lot of experience in that realm as well. So really kind of getting at this question of equity, which has clearly motivated so much of your work. I wanted to ask you how you think about the inherent tensions that come when deploying cutting edge technologies, and how you do that in an equitable way. And I ask that because there is a pressure to deploy cutting edge technologies in places where it's already safe, where there's already good options, where there's already a lot of foot traffic and things like that, not necessarily the people who would receive the most benefit. So, how do you think about answering that questions, and how do you think about who should receive these technologies, how they should receive them, and when they should receive them?
Right. It's a good question, and exactly as you said, historically we're just saying, okay, we're going to put this technology to areas that have cars with this kind of technologies, the same way that they're doing for electric vehicles. We're putting the charging station to places that are mostly the electric vehicles are going, and residents have it. But we are saying no, we have to look at the places that needs it the most, not the one that have it. And who needs it the most are the places that have more safety problems, the places that have more crashes, especially pedestrian bicyclist crashes and fatalities. So we need to look at those places and prioritize those areas. And the places that we are putting more like bike lanes, and if they are especially shared bike lanes. So we need to put technology to those areas to protect the bicyclists. So based on the equity standpoint, we have to go to where we need it the most. And we have been working with nonprofit organizations and with community organizers, and also with the cities and counties. And so we are kind of in the middle, and the private industry. So we are saying that we are not private industry as academia. We don't care about our own profit, and we don't as a public agencies, we don't care about what people vote for us next time or not. So we are agnostic. We are researchers. We do find out, we just get the data and analyze the data, and we just say what data says. And with that, we can inform people of the all of the benefits that they can get and how we're going to help them. And we can inform the policymakers how important it is and how it can help them, so they can choose or rank the different projects, and so they can fund this kind of projects or use this kind of technology for different projects to increase safety in different areas. And also we work with the industry to scale it and to do the installations and then all of that. So we are thinking that as academia, we are kind of the mediator between all of these agencies, and we can help to get the best products for people.
That does kind of get at another question I had, which was, what advice would you give to academics and researchers who want to be influential in a field that's predominantly dominated by developers and engineers? And I think what you were kind of getting at was that, you know, there's this sense of neutrality and objectivity. Is that kind of it?
Yes, so we should be neutral and agnostic. We are not, all we do is to look at the data and interpret the data and give the honest response and the honest answer of which project or which way is better to do. So we can do an analysis and we can give the results, but we should be fair and honest and also agnostic. Also, we need to work with all different agencies. We need to work with private industry. We need to work with public agencies and with people, communities and community organizers. That's how we can have a meaningful research and research implementation. As academia, a lot of academians, they just do theory work, which is great, and if theory is needed to go to the next step. But we in this center, we are doing more of applied research. So our research is like research, mostly using the research and making it implementable. So we are doing the research implementation. That's why we work with all of those agencies and scale it. I mean, we do some kind of testing and pilot here and there, and then it can be scaled after we show how it can work in the best way for to increase safety, mobility, and equity for all.
I think this is a good opportunity to integrate a question from the audience that is kind of piggybacking on this thread. And that is, when you're cooperating with different agencies and developers, what are you trying to measure? What are the figures that you can point to with respect to the built environment that would lend one to want to implement connected and autonomous vehicle systems to promote safety, to promote equity? Would that be like, near misses, zero car households in a given area? Like what are you trying to measure and demonstrate to other stakeholders?
Yeah, there are different indices that we show, but for the safety, yes, near misses is one of the most important ones, because we say we cannot just look at crashes. Crashes doesn't happen that often to just do the decision based on that. And a lot of safety researchers, they look at the safety surrogate measures. And with this technology, we can look at all of the near misses. So let's say the intersection that we have the equipment on, during the one whole year, we had 2 crashes, but we had thousands of near misses. So looking at that, like those near misses could become a crash, and how we can prevent that, and how we can figure out what was the reason of that near misses. Was it the human error? Was it the traffic signal? Was it the geometry? And how we can look at that. We are looking at pedestrian, like unsafe crossing of pedestrian, how they are walking, so we can see that the walk path that they're getting out of, for example, getting out of the bus instead of going all the way to the intersection and past the intersection crossing, they just pass through the place that there's no crosswalk. And so we can look at all of that and find out what is the best way to mitigate all of those problems.
How do you think about integrating community feedback into the CIV deployment process? And I ask this because I think it matters what community we're talking about when we're thinking about community engagement and the type of engagement that we are receiving from them. Um, it's not controversial to suggest that the loudest voices in a community tend to be the angriest. And the reasons for their frustration may or may not be justified or might be motivated by factors that might not be relevant to the needs of the broader community. So how do you kind of maybe sort those kinds of complaints or attitudes, and how do you make sure that when the community does speak up and it is representative of the broader community's needs, that it gets to the decision making table?
Right. It is $1 million question because, as you said, it's the communities that are louder, they may not be the ones that really need the most, or they might be even right. They just want something that is best just for me and for my community in the expense of other communities. And the communities that do not have much of voice, we need to be voice for them. But one thing is to education and awareness of all of these. The technology, most people, even very well-educated people, they don't know much about connected and automated vehicle technology. All they know is Teslas and some self-driving cars, mostly. So we need to increase that awareness, having more of so those kind of, I don't know, webinars and community outreach, going to town halls and videos that we are making right now. We are making like my car does what video that we are talking about, like all of these new cars that have a lot of ADAS features. Many people don't even know what are the features that their car has. And the dealers, when they're selling the car, they are not sitting and teaching you all of the gadgets and the buttons and what it do. So we are making videos free, available to everyone, so that they can figure out like how to use this technology. The same way we need to reach out to the communities and community organizers and advocates. First, for them to understand what is this technology, what is it doing for them, and how beneficial it is. Then they can ask for what they want, and it is good for them. For technologies, probably is easier, but something like complete street is so hard because a lot of communities are so against it because they want to drive their car having a wide street for their cars. And so the ones that do not use bicycle, they don't care about having bicycle lane and a separate lane for that, or all of that. So the more education, the more awareness that we give them, and maybe a little bit of push, then after we put it, then they're going to see how it benefits them, how like even their kids can go by bike to their schools, how themselves they can go by bike here and there, and it's not all about cars. So it is a hard way to do, but we can and we should do that.
Do you think that your personal background as a multidisciplinary thinker has given you more of an ability to see that big picture? You know, because you're integrating knowledge of economics, sociology, computer science. Like I think you're pretty unique in the academic world because you're able to merge those worlds, the technical and the personal, very effectively. Do you think that has made you a better leader and a better thinker when it comes to thinking about transportation issues?
I believe so. I hope so that I have done that. As an engineer, we are just problem solvers. We just look at one problem, we're going to solve that specific problem. But if we look at as economists or social scientists, you need to go back and look at a bigger picture and look at okay, this is one small problem, but how it is related to a bigger and wider community and wider society, and how we can do that. And definitely multidisciplinary has helped me to connect all of this together, and especially like from computer engineering to economic to socioeconomic systems engineering and all the way to transportation. All of that are kind of related to each other, and transportation is a multidisciplinary field. We cannot have it just engineers. And that's why in our center, we have more than engineers. We have all different kinds of engineering, from civil engineering, transportation engineers, electrical engineers, industrial, but all the way to sociology and psychology and business, and all of that faculty and researchers are working with us, because transportation is more than just an engineering problem.
My last question is always, what advice do you give to rising transportation professionals, academics, or just people who want to make better cities? But I think in your case, I would also add, what advice would you give to young women and young immigrants, especially in trying to make their way in this field?
Yes. So I always say to women, we have to, women, especially women, minority women, we have to work harder, and we have to uh, prove ourselves. So just don't feel pushed back. Just fight and go and continue and do work harder and harder, um, and you see that when you see women that are in some positions like me, like our department chair and others, when you see in transportation, and other in like USDOT and MDOT, when you see all of those women, you can say, if she could do that, I can do that as well. I always tell my students, if I could do that, I came from a third world country, a developing country, coming all the way to here and becoming the director in here. If I could do that, you can do that. But it needs more work and more proving yourself, but it's worth it. And the more women that are in this field and and in the workforce, you attract more women, because they see you as a role model, and they come and they become more comfortable, because when you are in an area that's only you, it's hard, and you don't have that much of that network. But when there are more and more of them, it becomes easier. So I hope I am a role model. I can be a role model for young professionals.
Mentors matter. Dr. Mansoureh Jeihani, thank you so much for joining us on Smarter Transportation Talks. And thank you to everybody who attended. If you'd like to see the full episode again or highlights from this show or previous shows, you can see it on youtube.com at our YouTube channel, and on our social media channels as well. Thank you all for joining, and I'll see you next time.